Hey everyone, Mr. Russell here to talk to you about 45, 45, 90 special right triangles. So on the screen right now, I have a couple examples, but before I get to that, I want to kind of talk about how the 45, 45, 90 triangle works. So over here to the left, we have an example using the relationships that we established in class. Okay, so first of all, the reason why we call it a 45, 45, 90 is because those are the measurements of the three angles inside the special right triangle. One angle is 45, another one's 45, and the other one is 90. Okay? So the cool thing is, if you remember back from when we talked about isosceles triangles, way back in chapter 3, we established that if a triangle has two congruent angles, it also has to have two congruent sides, right? And conversely, if it has two congruent sides, it has to have two congruent angles. So that's why the first thing we established when it came to this 45, 45, 90 triangle is that, well, since the angles are congruent, these two base angles, the sides opposite from those angles also have to be congruent. Right? When I say opposite, I mean across the triangle from those angles. So that's why when it comes to these relationships we have here, the two legs, we say both have a length of x because they have to be the same. They'll have the same measurement. Okay? And then in class what we did was we looked at a couple examples. First, we said, all right, let's make up a side length for one side. Maybe it's 5. Well, if one leg is 5, the other one has to be 5. And then we can use the Pythagorean theorem to figure out what the length of the hypotenuse would be. Right? And we did that. And we did that for a couple different side lengths. And what we figured out was that whenever a right triangle has two congruent sides, the hypotenuse always ended up being whatever that side length was times the square root of 2. So actually, the relationships we have here are a shortcut to the Pythagorean theorem. It makes it so we don't have to use that theorem each and every time. Okay? So what you need to remember is that the legs are congruent, and then the hypotenuse is whatever the leg is, or one leg is, times the square root of 2. Now let's watch how this happens in an example. So this first one here, all right, I'm looking at this right triangle. I know it's a 45, 45, 90 special right triangle because it tells us that the two legs are congruent. Again, since the two legs are congruent, the angles opposite from those legs have to be congruent, which would make it a 45, 45, 90. Okay, so first of all, since one of the legs equals 3, we know the other leg also has to be 3. So nice and easy, we can already say that x has to equal 3. Okay? And then using the relationship, I want to figure out what the hypotenuse is. Well, since the legs are 3, the hypotenuse has to be that times the square root of 2. So y is going to equal 3 square root of 2. And folks, that's it. X is going to equal 3. And y is going to be 3 square root of 2. Okay? So there's the first thing to remember. Whenever we're going to leg to hypotenuse, okay, we're going to multiply by the square root of 2. Now if you look at the second one here, okay, we're not given a leg. What we know, the side length of 14 root 2, is the side opposite from our right angle. And we know that the side opposite from the right angle is always known as the hypotenuse. So in this example now, we're going backwards. We're given the hypotenuse, and we want to go back to figure out what the leg was. So think about the opposite. If we had to multiply by the square root of 2 to get the hypotenuse, to go backwards, we're going to divide by the square root of 2. Okay? You think about this. The hypotenuse has to be the longest side on that triangle. So if I'm trying to find a leg, which has to be a length that's less than the hypotenuse, it makes sense that we would divide to get a number that's smaller. So we're going to go ahead and take the hypotenuse here, which is 14 square root of 2. And to go back to find the leg, we're going to divide that by square root of 2. And this one's really nice because since we have a square root of 2 on top and a square root of 2 on the bottom, those are just going to cancel out. And then we're left with the legs each being 14. So in that example, x and y both have to be 14. So the big takeaway from this slide, everyone, is that if we are giving a leg and we're trying to find the hypotenuse, we're going to multiply by the square root of 2. If I know the hypotenuse and we're trying to find a leg, we're going to divide by the square root of 2. Okay? So I'm going to show another example to you guys. Let's look at this one. Now this one's a little bit different. So let's think through this one. First of all, it is a 45, 45, 90 special right triangle because since the legs are congruent, right, we know the opposite angles also have to be congruent. Okay? Now, we got to figure out this 18. Is that one of the legs of the 45, 45, 90? Or is that the hypotenuse? So let's look at what angle it's across from. Since it's across from our right angle, that one has to be the hypotenuse, right? Across the right angle is the hypotenuse. So, then we ask ourselves, if I'm given the hypotenuse, how do I go back to figure out what the leg is? Oh, we're going to divide it by the square root of 2. So let's take whatever it is, and we're going to divide it by the square root of 2. So in this case, my hypotenuse is 18. So we're going to take that 18, and we're going to divide it by the square root of 2. Now, this one's different than the one in the previous slide because, went the wrong way. The one we're looking at here, which is 18, there is no square root of 2 like we had here. That's just going to cancel it out. So instead, when we have a square root on the bottom, we do something known as rationalizing the denominator. And that's what we're going to do here. Okay? If you want more help with the idea of rationalizing the denominator, you can look at the other video on the Chapter 8 page of help videos on dividing radicals. So what we're going to do is we're going to rationalize that by multiplying both the top and the bottom by the square root of 2. Okay, multiply across. 18 times the square root of 2. Well, one's inside a radical, one's not. So I'm going to leave it as 18 square root of 2. On the bottom, we have square root of 2 times square root of 2. Both of those are inside radicals, so we can multiply their radicands together, and we would get the square root of 4. But the whole reason we did that was so we'd get this perfect square that we can simplify. What is the square root of 4? Oh, well, that's just 2. So that's going to simplify to a 2. And then we can divide 18 over 2, since they're both outside radicals, and get 9 square root of 2. So that means one leg would be 9 square root of 2. And we know in the 45, 45, 90, both legs are congruent. So the other leg would also be 9 square root of 2. Okay, so those are the main ideas for 45, 45, 90 special right triangles.